Welcome to Khetz Tutorials, and in this video I'll be talking about the midpoint theorem. So just basically started a series and I'm talking about theorems which are linked to triangles, and this is one of them. If you haven't checked the other videos, please do. It's going to be quite helpful to you. And so let's just get started. Let's get right into it. If you haven't subscribed, please subscribe, and if you like this video, just go ahead and give it a thumbs up. If anything which I say isn't clear, please let me know in the comment section. So we are talking about the midpoint theorem, and before we talk about it, we have to really know what it is. And this is what the midpoint theorem says. It says if a line segment, it joins the midpoint of two sides of a triangle, the line will be parallel to the third side and equal to half. Sorry about that. And equal to half of the third side. Okay. So it says, let's read it like all at once, or let's read all of it. It says, if a line segment joins the midpoints of two sides of a triangle, the line will be parallel to the third side and equal to half of the third side. Okay. So what does that mean? So let's draw a triangle. A triangle basically looks something like that. Okay, so just imagine it's actually closed at the bottom. I just want to explain what this means. Don't really mind that. Okay, so let's draw another line because it's talking about a line segment which joins the midpoints. So joining the midpoints, so let's say this is the midpoint of this side, which is AB. Let's call it D, and here we're going to call it E, and this is going to be C. So let's say this here is the midpoint. So the midpoint, if you have a line, and we are told that this is the midpoint, so midpoint. So if this line were 10 meters, then the midpoint would divide this line into 5 meters and 5 meters. So now we're told that, or the theorem says, if a line divides AB and AC at the midpoints, right? So this means that and to indicate that the sides are equal, we use the same number of slashes or the same number of lines. So which means if D is the midpoint, it means that AD and BD are equal. Don't mind the proportions, or if I drew this to scale, it's not exactly to scale, and that is why in the diagram you see that AD and BD are not exactly the same. But we can assume, just so you actually understand the theorem, that is my point. I want you to understand the theorem. I haven't exactly drawn this to scale. So we are saying that this is the midpoint D, and this means that AD and BD are equal, or DB. And also this means that AE and EC are equal. So the theorem says if a line segment joins the midpoints of two sides of a triangle, so this line segment DE, it joins the two midpoints of the two sides AB and AC. then the line will be parallel to the third side and equal to half of the third side. So this is what that means. We can conclude, if we have a case where a line joins the midpoints of two sides of a triangle, we can conclude, the theorem says we can conclude that this line is parallel to the third side, and if its size were x, then this would be 2x, because the last part of the theorem says it is parallel, so parallel to the third side. We did that with the green arrows, and equal to half of the third side. So if the third side is of value 2x, whatever x is, we can actually even use values and say, let's say the third side was 10. So let's say the third side was something like 10. Then that would mean that the value of the line segment DE is 5, because of this last part of our theorem, which says parallel to the third side and equal to half of the third side. So that is what the midpoint theorem is basically saying. That is all there is to it. If you are given, or if you find out after doing a few calculations that AD is equal to DB and AE is equal to EC, then you can actually make the conclusion that DE is parallel to BC, and not only that, but then DE is half of BC. So if you do some calculations on a triangle, let's say you're given values on a triangle and you find out that AD is equal to DB and AE is equal to EC, or if you're given these symbols which show that the sides are equal, the blue symbols and the red symbols, if you're given those and you conclude, or you know for sure, that AD is equal to DB and AE is equal to EC, then you conclude that DE is parallel to BC and DE is half of BC. Now we also have something which is quite interesting. So that is all with regards to the main thing, or the main midpoint theorem. There's also something of note, or something which you have to know, and that is the converse of this theorem. So now I'm going to talk about the converse of the midpoint theorem. Now, in any case, just to go back up, in any case, if you're asked to do something and you see that the value of a certain, so let's say you're asked to find the value of DE or the value of BC given whatever, and you actually see that you can apply the midpoint theorem to that question, you can just simply write the values, you just simply calculate your values, and in brackets just say midpoint theorem, right, as your reason. Now coming back to the converse of the midpoint theorem, it says if a line joins the midpoint of one side of a triangle and is drawn parallel to another, so another side, it bisects, so bisects, let's write that properly, it bisects the third side and is equal to half of the length of the side it is parallel to. Okay, so let's just read that and understand what it's actually saying. It says, if a line joins the midpoint of one side of a triangle and is drawn parallel to another side, so let's draw a triangle to actually put this into practice. All right, and I'm just gonna fix this. Let me just fix this just so at least the lines are on the same level or something like that. Okay, that's a bit better. So if a line, let's draw that line, it's gonna occur obviously somewhere here. Whoa, using this. Okay, so the line is gonna occur somewhere there, and we can say if a line joins the midpoint of one side of a triangle, so let's say we know that this is the midpoint of this side AB. So this line, the red line DE, joins the midpoint of one side of a triangle, and it is drawn, we are told that it is indeed drawn parallel to one side, right? So if these are the two things that are given, so the first thing would be that the line joins the midpoint of one side, and that the line is parallel to one side. So we know for sure that the red line cuts there, which is the midpoint, and that it is also parallel to one side of the triangle. And that information is going to lead to the conclusion that it bisects the third side, which is this side, which means it also cuts at the midpoint of the other side, or the third side, and it is equal to half of the length of the side it's parallel to. So DE is parallel to, so conclusions, it also cuts AC at midpoint. The second conclusion is that DE is equal to half of BC. That is what this Converse theorem is saying. So if a line joins the midpoint of one side, so in this case we're given part of the information, and part of the information is that the line joins one midpoint and it is also parallel to one side. And from that we can make the two conclusions, that the line also cuts the other side at the midpoint, and that the line itself is half of the line which it is parallel to. And that is the converse of the midpoint theorem. If a line joins the midpoint of one side of a triangle and is drawn parallel to another side, it bisects the third side. And this word bisect means to cut in half. So it bisects the third side and is equals to half of the length of the side it is parallel to. So that is all with regards to this video and the midpoint theorem. If you like the video, just as I said previously, go ahead and give it a thumbs up. And if you haven't subscribed, please subscribe. If anything, just about anything isn't clear, please leave a comment in the comment section, and I'll see you guys in the next video.